Polymer. Polymer is a large molecule composed of multiple repeating units. This creates a wide range of combination of atoms that affect the properties of the polymer. Polymer is divided into three main groups: thermoplastics, thermosets, elastomers. This presentation will only cover thermoplastics polymer. Thermoplastic. Plastic material, polymer, that can be molded or pliable under specific temperature and solidifies upon cooling. Have a relatively high molecular weight. Change between molecule through intermolecular force. Can be broken down with increase in temperature. Can be recycled. Example of thermoplastic: polyvinyl chloride, PVC. Polyesters. Polycarbonates. Here's an example of production of PVC or polyvinyl chloride. Now let's take a look at the video by YouTubers Markedkillen about PVC.
Polyvinyl materials comes from very simple beginnings: salt, water, limestone, and coke. In the manufacturing process, salt and water plus electricity produce hydrogen and chlorine gases, which combine to form hydrogen chloride. Coke and limestone are combined to form acetylene. These two gases are then combined in turn, heated, compressed, and cooled, and thus converted to liquid form. The result? Vinyl chloride. A single drop contains literally billions of molecules in a seething, chaotic world of their own. The addition of a catalyst to vinyl chloride works a startling change. The catalyst, like a top sergeant who never joins the rookie ranks, still gets plenty of action.
All right, you guys, fall in on the double. Mash it up!
The effect of the catalyst makes these molecules grow and hook together in long, strong chains. This bonding reaction is known as polymerization. It gives rubber and plastics their resilience and toughness, their ability to stretch and return. In this case, the process of polymerization results in the material polyvinyl chloride. This material is plenty tough, but of no practical use until a plasticizer is added. The plasticizer's softening influence makes these tough little characters pliable and workable. Thus was created a new material known as Geon, from which Corosil products are made. A material which brought into being new plants, new jobs, and a vast array of new products which contribute to the safety, comfort, and the beauty of our daily lives.
Mechanical properties of PVC stated by vinidex.com is shown in table shown. Here is some example of application of PVC. Medical application. Transport. Building and construction. Toys. Consumers' goods and everyday life. Packaging. Art and design. Polyester. Also known as polyethylene terephthalate or PET. Used widely in clothing and fabric. Here is an example production of polyester. Now let's take a look at video uploaded by Rendell's Certified Cleaning Service from YouTube.
In this video, I'm going to talk about 5 things you should know about polyester. Number 1, heat resistant. Polyester is very heat resistant. It has a melting point of 480 degrees Fahrenheit to 550 degrees Fahrenheit. Number 2, resists bleaching and fading. This is because it's dyed with a dispersed dye or solution dyed method, which makes it very resistant. Number 3, environmentally friendly, meaning it's usually made of recycled plastic bottles. Number 4, does not resist oil stains. And number 5, crimp loss, meaning fibers are more likely to crush and mat. Improvements have been made in the newer market of carpeting, but it's still just a characteristic, not a defect. And those are 5 things you should know about polyester.
Here's a table comparing mechanical properties of polyester, dry fabric and wet fabric. Application of polyester is mainly in fabric such as industrial and commercial textiles, apparel, carpet and rugs, household, institutional textiles, interior textiles. Polycarbonates contain carbonate groups in their chemical structure. Easily worked and molded and thermoformed. Polycarbonate can undergo large plastic deformations without cracking or breaking. Can be processed and formed at room temperature. Suitable for transparent or electrically non-conductive parts. Transformation technique used. Extrusion into tubes, rods and other profiles including multi-wall. Extrusion with cylinders, calendars, into sheets. Injection molding into ready articles. Here's a video about polycarbonates posted by ChipTip Video in YouTube.
Polycarbonate is a thermoplastic polymer, polyester or metacarbonic acid, and dihydric alcohols. The most popular, bisphenol polycarbonate, is produced by fourth generation of bisphenol A and by interesterification of a fused electrolyte with bisphenol A. Polycarbonates are transparent in colorless plastics. However, they can be dyed in any color. Electrical properties of polycarbonate are dielectric capacitivity 2.9, relative permeability 0.866, electric strength 15 to 67 kV per millimeter, loss factor under 1 MHz 0.01. Polycarbonate is a more expensive material in production than other plastics, therefore it is used only in the cases when other plastics have not enough toughness and mechanical strength that is necessary for production of CDs and DVD discs, cabinets of electronic components and equipment, optical lenses, lamps, plate illuminators, and sectional transparent roofs for glazing of winter gardens and hot houses, submersible chambers for cameras, for safety screen of solar arrays, shutters, covers, as packaging materials and materials for production of boxes, bottles, bodies of cars, safety helmets, and protective visors. Transparent sheets of high-impact polycarbonate are used to produce a so-called bullet-resisting glass. So, for example, the cockpit canopy of a fighter F-22 is made of this material. Moreover, polycarbonate serves as material for chambers of some cameras and mobiles, notebooks and other devices, as well as for production of long-lived documents such as identity cards and pages of passport, the so-called data pages. Due to good biocompatibility, it is used for production of various medical one-use instruments. Market share of polycarbonate in global world consumption of plastics is 2.2 million of tons per year, or about 1.3%.
This table shows mechanical properties of polycarbonates taken from Wikipedia. Application of polycarbonate includes electronic components, construction materials, data storage, automotive, aircraft, railway and security component, niche application, medical application, phones. Thank you for watching.